Hello, I'm Stephen Rakusik with South Dakota Public Broadcasting.
I'm Dale Droege, Professor of Biology at Dakota State University.
And today we're going to dissect the cow eye. Why the cow eye?
Well, cow eye is probably the main reason we use them in the classroom is that they're easy to obtain. You can get them from supply houses, from the packing plants. And then also it's very large, so that's, they are. And it's a mammal eye, and a mammal eye, humans are mammals too, and so the structures are virtually identical.
Absolutely. I mean, size is unbelievable.
Yeah, they're very large.
And this looks huge. Why does it look so big?
Well, this one looks so big now because, unfortunately, when they take them out, they're covered with fat and connective tissue. So you have a lot, the eyeball itself is sort of embedded within all of this fat. So we'll have to cut a lot of this away.
What's nice too maybe is when the kids start dissecting this, you can kind of tell the difference between maybe the connective tissue, muscle, and fat.
Yeah, and in fact you can sort of see on the back here already, you can see the fat, of course, and then these reddish structures with the striations are muscle. And these are the extrinsic muscles which control the movement of the eye. So you can move your eye to side and up and down. So they have and then of course in the cow then these muscles are relatively large.
Anything else to look for on the outside?
Well, and one thing for us are coming out the very back, you'll see this little stub that looks like a cord, and that's the optic nerve, which of course carries the signals from the eye to the brain to be interpreted. So we want to, that's the only structure on the outside here we don't want to damage. We want to cut around that as we go.
As far as starting the dissection, where do you suggest
Well,
starting?
like I say, first you just have to start trimming this up, and this is pretty, is not fine work by any stretch of the imagination. We'll just start cutting away that muscle and
maybe the
fat.
only thing would be maybe like it's kind of hard to hang on to, maybe slipping as far as kids cutting themselves.
Yeah, you'd have to be careful. Cut away from yourself. Maybe not even cut off smaller pieces maybe than what I'm doing if you've got time. But you just have to have some patience and just keep cutting away that tissue. And I say there isn't too much to damage here as long as you don't go into the eyeball itself. And just trim away, and then you want to just be careful here around the optic nerve. It's nice to be able to preserve the optic nerve as we cut that tissue away.
Maybe nice too. There's a lot of fat there. Maybe to have all the kids in a group, maybe try it if to feel the difference between the muscle and the fat.
Everybody should have their gloves and be ready to go, and so they could cut. Yeah, and it's pretty dense tissue. I'd say it doesn't cut easily sometimes.
We do have one here
Yeah, and I think in the interest of time, we can just go ahead and
see a huge difference there.
Take that one away, and I'll hold this one. Yeah, so you see with a little patience, you cut all that away, and see here's the optic nerve on the one, and here's you can see the optic nerve extends into the eye, and you can see why they call it an eyeball. It has that spherical shape to it.
As far as identification on the outside now, what do you want to show first?
Yeah, so let's start with some identification here. Maybe you want to hold that for me? Okay, so here is the eye capsule itself, and you can see in the front is this transparent or relatively transparent part of it. This is the cornea, and so the cornea is where the light enters the eye. It's a protective outer layer. It is a little opaque now, but that's with the preservation and death. I mean, in life that would have been transparent. And then that is actually continuous with this connective tissue, which is the hard, tougher outer covering of the eyeball called the sclera. And so the sclera is mostly connective tissue in that, and it maintains the shape of the eye and protects the inner part of the eye. And then of course, extending out the back, the optic nerve. So pretty much that's all you can see, pretty much externally.
Hello, I'm Stephen Rakusik with South Dakota Public Broadcasting.
I'm Dale Droege, Professor of Biology at Dakota State University.
And today we're going to dissect the cow eye.
Yeah, you can either use the scalpel to make a slight incision, or you can go in with the scissors and just poke in. But you want to poke into the middle of the eye here, kind of halfway, kind of like the equator if it were a globe. And then you just use scissors to extend that cut around.
How deep do you want to go here?
You don't want to. You really can't damage too much, but you kind of like you're cutting a piece of paper. You want to keep the bottom part of the scissors up against the body, the scleral wall. And if you just keep cutting, it's pretty easy cut. Your scissors are sharper than these anyway. And go all the way around.
You said there's no way of really messing up too much if you're in this section.
I don't think so.
What happens if you're farther towards the front? Is there
you don't want to. Yeah, you kind of want to stay in the middle. You want to stay away from. There's some structures, the ciliary body and such, that you'd really like to stay away from. So let me make that last cut. I know we have some more information on this on the on the website too.
There'll be photos and stuff that'll go along with this.
Anyway, so here things are, and if you cut the eye and then you just open it up.
I can hold it here for you.
Okay, just open that up like that. I think maybe I'll use a pair of forceps here. And first of all, if you look here, you see this kind of translucent, almost flesh-colored layer here. You notice that's against the back of the eye. That's the retina. And so the retina has the photoreceptors. That's where the light is, hits and is interpreted by the photosignals, the rods and the cones. Cones more for color vision, rods for black and white. And those signals then are, the light's turned into electrical signals, which are transmitted into the optic nerve. So the retina is nervous tissue. It is continuous with the optic nerve. And you can see how you might get a detached retina. The retina is not very securely, it's not attached in any way to the inside of the eyeball. Instead, it just spreads around that, and it's, so it can, and it's the only place it is attached is at the optic nerve.
And at that point, is there
vision, that's called the optic disc, and there are no photos. So this, maybe turn the light right there. That right where the optic nerve comes in, that's called the optic disc, and there are no photoreceptors there. So that's actually sometimes called the blind spot. And your brain kind of compensates for that. So only when you do special tests, you just discover that there's this little spot here where you don't have vision. All right.
So go ahead and just kind of pull it here, or should I?
Yeah, and then we can, say here, and then extending, you might, obviously students will notice immediately is the eye's full of this big clear jelly-like substance. This is called the vitreous humor, and so it fills the inner part of the eyeball and mainly helps the eyeball keep its shape. So things are, so light is transparent, light passes right through that, and so you probably want to just kind of pull that out of there. It's kind of
like a jelly-like.
Yeah, it's very jelly-like, and it does kind of want to hang on, so you kind of pull it all out of there. There it goes. Boop. And so it's kind of gloopy, and things are. And now we can see some other structures in there. Let's do the back first. You can see, here's the retina, and if I pull the retina down off of there a little bit, you can see that there's a dark layer there. This is the choroid coat. The next layer, you can see that layer is only loosely attached again to the sclera. And the choroid has richly supplied with blood vessels and things. It provides nutrients to other parts of the eye.
It's awful dark too.
And it's dark and prevents light from scattering, getting reflected around. Now, interestingly though, and this is one difference between cow eyes and human eyes, is cows, cats, other mammals have a shiny reflective layer in the back of their choroid. It's called the tapetum lucidum, and the tapetum lucidum then actually encourages or promotes the reflection of light rays, and so these animals have much better vision in low light situations. We often say cats can see in the dark. Well, they can't see in literal darkness, but they can see much better in those kinds of low light situations, as can cows. It's also what's responsible for if you shine a flashlight in the eyes of a animal, and you get that eye shine back. You see that reflection. It's reflecting off of this bright tapetum lucidum layer in the back of the eye. So it's kind of an interesting feature.
Yeah, something we don't humans.
Would not see that in a human eye. It would be totally dark.
Anything else to see back here?
I don't think there's too much. You can see this. It's kind of nice here. You can see the scleroid coat on the outside. It's tough, and then you can see the choroid, this next layer in, and then the inner layer, the innermost layer, is the retina. So sclera, choroid, retina from outside to inside.
And something like the books might have something about the fovea centralis or macula.
Yeah, and you can't really see those. The fovea centralis is an area in the human eye that has a high concentration of cones, which allow for very visual acuity, and for color vision. And it tends to be an area where light tends to be focused a lot. But it's such a structure you can't really see it with the naked eye. But it would be on the retina then, would be in an area with a lot of photoreceptors, cone photoreceptors.
Okay. Should we move to the
front and if we go to the front part of the eye, whoops, here we go. Steve has it here. And of course, right away you notice this big spherical kind of thing sitting there in the middle, that's the lens. And so the lens focuses the light on the retina. And you can see in here it looks like it's almost plastic. It is kind of, at this point, it's a layers of membranes that are on, but it is a living tissue. And it's situated right in that opening, and it's attached to these ciliary processes, or this ciliary body, these striations here. And so it's those muscles in the ciliary process that can change the shape of the lens. And you may, if you said, the lens is, in life, the lens is a much more flexible structure, and the muscles can pull and change the shape, which allows your eye to accommodate for near and far kinds of things, or movement and things in the light, and change the focus. So I think at this point we can just pull that out, and I think we'll have a close-up look. You can see the suspensory ligaments, but that lens kind of just pops right out of there. Kind of a cool thing. And that lens, you'll notice things are very hard, more hard now in preserve than it would be in life, but you can see it'd be transparent, light could pass through it, but it's not a perfect sphere. It has a little shape, to refract the light and focus it right on the retina.
This can become cloudy, is that right? Or
yeah, and that could become cloudy. You can lose, the ability of the lens to focus light.
I know some fluid just kind of pouring out. I'm going to pour that out here.
Yeah. Once we pulled that lens out, there's a space. Maybe you can see there's a space here between the lens and the cornea. So the cornea is on the outside and it's inside, and that's called aqueous humor, and it's much more liquid than the jelly-like vitreous humor. And it actually supplies the nutrients, or carries the nutrients, to the various parts of the cornea and things like that. The cornea is another very tough tissue. It's connective tissue, and so it needs to be. It doesn't have blood vessels in it. It has to be. The nutrients have to come from other sources, and that is the aqueous humor. Okay. And again, from the back, we can see the striations of the ciliary body, and then right in here, right around this opening, this space, is the pupil. And so this pupil is the space where light enters, comes through the lens. And of course, right around the pupil is the iris. And so this tissue here is the iris of the cow eye. It's not as colored as it is in people. And that iris has muscles then that control how the diameter of the opening of the pupil. And so, we're familiar with this pupils dilating and pupils constricting. Under low light situations, your pupil opens up, and so more light can get in. Under high light situations, bright light, your pupils will contract, and this opening here will get smaller, so less light comes in and don't damage your eyes. And see, this one's been pulled out. If once you've looked at all those structures, you can usually get. I say that. Sometimes you got to find a place where it's loose. There it goes. And once you get that kind of loosened, you can then pull that out.
I'll let you grab it there.
I probably better have it on my hand here. Not sure I have the right tool either, and it tends to hang on the ciliary body.
It almost looks like the choroid's continuous with the ciliary body there. It looks like.
Yeah, I believe yes, they are. And try to hold that.
Very slippery.
Yeah, slippery, and you can see it. There it goes. But anyway, you can remove that, like the one that Steve has there, and the choroid. You can see here's the ciliary body extent, and it's continuous with the choroid. And then when you take that all out, there's the scleros left. You can see where the sclerus coat, the sclera, is continuous with the cornea. And now you can kind of see how transparent that cornea is. You can see my finger through it. That. So light enters, passes through the cornea, through the opening, the pupil, in through the lens. The lens then focuses the light on the retina, and then those signals are sent to the brain and interpreted as vision. So
not really complicated, but yet it works fantastic.
It works extremely well, and say the level of visual acuity that most vertebrates, in particular mammals, have is amazing. And we depend greatly on our visual senses, probably more than most other mammals.
Thank you so much, Dale. And
I'll
remind you to also visit the website, because we'll have additional photos, different diseases, conditions that affect the eye.
We're all very sensitive to things that happen to our eyes.
Yeah, that'll be covered in detail on the website, so definitely check that out. And thanks again, Dale, so much for coming here today.
My pleasure.